A video recently exploded across the internet claiming to show the interstellar comet 3I Atlas floating through space in stunning detail. Its slow, glowing motion looked mesmerizing, almost like something out of a sci-fi film. For many, it seemed too perfect to be fake, but there was just one problem. It wasn't real. Today, we're going to break down what that viral footage actually was, how scientists debunked it, and why the real 3I Atlas is far more incredible than any fabricated clip. Let's dive in. It all started on October 27, 2025. A short low-light video was posted to X, formerly Twitter, with the caption, "New 3I Atlas footage just dropped." The clip showed a glowing fluid object drifting through dark space, smooth, organic, and oddly captivating. In just a few hours, it had gone viral. Thousands of shares, reposts, and even AI-generated image summaries labeled it as authentic footage of 3I Atlas, the interstellar comet currently passing through our solar system. But astronomers weren't convinced. The clip didn't show any of the normal signs of deep space footage. No background stars, no visible coma or tail, and no irregular motion caused by cosmic dust or light distortion. In real comet images, you always see scattered noise, faint trails, and light distortion due to long exposure photography. This video, it was almost too clean. That's when the fact-checkers stepped in. A team from Lead Stories used reverse image search and metadata tools to try and find the source. Their search turned up nothing in astronomical image databases, no match in NASA's archive, no ESA connections, and nothing linked to any telescope that had actually observed 3I Atlas. Eventually, they reached out to Professor Jack Gilbert, a microbiologist from the Scripps Institution of Oceanography. His answer ended the mystery instantly. The video wasn't from space at all. It was footage of a paramecium, a tiny single-celled freshwater organism, filmed under a microscope. Paramecium move using hair-like structures called cilia, which beat in coordinated waves, creating a graceful, flowing motion. When viewed under specific lighting and cropped and darkened the way the viral clip was, the movement looked cosmic, but it was microscopic. In reality, what the world saw wasn't an interstellar object millions of miles away. It was a microorganism in a drop of water. So how did a biology clip turn into a viral space video? It's a classic case of context stripping. What was likely an educational science video, maybe part of a biology class or research project, was cropped, darkened, and posted online without explanation. Someone added a bold caption about 3I Atlas, and the internet ran with it. That's the problem with content in the age of social media. When a mysterious visual is paired with a confident claim, it spreads faster than truth can catch up. Even worse, some AI-generated tools began repeating the false label 3I Atlas footage, further reinforcing the error. And just like that, a microscopic creature became the star of a made-up interstellar encounter. By the way, if you're finding this breakdown helpful, make sure to subscribe for more deep dives into space science, cosmic mysteries, and the truth behind trending astronomical stories. Let's keep curiosity grounded in real discovery. Despite the confusion caused by that viral video, the real 3I Atlas is not only authentic, it's one of the most intriguing interstellar discoveries of the decade. It was officially detected on July 1, 2025, by the Atlas Survey System in Hawaii, which scans the skies for fast-moving objects that could pose a threat to Earth. But this object wasn't just fast, it was unbound. Astronomers quickly noticed that it followed an open hyperbolic trajectory, meaning it wasn't looping around the sun like most comets or asteroids. Instead, it was flying through, straight from deep space, never to return. That made it the third confirmed interstellar object ever observed after Oumuamua in 2017 and 2I Borisov in 2019. What makes 3I Atlas stand out even more is its chemical signature. Observations from world-class facilities like Gemini South and the European Southern Observatory detected a classic comet-like coma and faint tail, indicating activity from sublimating ices. But spectroscopy revealed something unusual, a higher ratio of carbon monoxide to water ice than is typical for comets born in our solar system. This composition strongly suggests that 3I Atlas originated in a much colder region, possibly around a distant star in a far-off corner of the galaxy. Interstellar objects like this are incredibly rare, and each one gives astronomers a precious look at materials and conditions from outside our solar neighborhood. These aren't just frozen rocks, they're natural time capsules, carrying dust, ice, and elements that could predate Earth itself. Studying 3I Atlas helps researchers build a broader understanding of how planets form in other systems, and how similar or different those systems might be compared to our own. While the viral video that misidentified a paramecium as the interstellar comet 3I Atlas was incorrect, it still offers an unexpected lesson about patterns in nature and in perception. The fluid wave-like motion of the microscopic organism, captured under a microscope, resembled the flowing tail of a comet moving through the vacuum of space. The comparison is, of course, purely visual, but it reveals something interesting. Across vastly different scales, from microscopic life in water to massive celestial bodies in space, similar dynamics can appear when viewed through the lens of motion and light. Both paramecium and comets interact with their environment in ways that produce rippling, graceful movement. For the paramecium, it's the motion of cilia, tiny hair-like structures, beating in waves to move the organism. For comets, it's the outgassing of dust and gas, creating dynamic, ever-changing tails that trail behind them. The mechanisms are entirely different. One is biology, the other astrophysics. But the human brain is wired to recognize familiar shapes in motion, even where there's no direct connection. This misidentification also reinforces a deeper point. Scientific claims must be backed by verifiable evidence. Just because something looks cosmic doesn't mean it is. Real astronomical discoveries are made through repeatable observations, precise measurements, and peer-reviewed studies. In contrast, misleading content often spreads because it's mysterious and visually striking. Ultimately, this case highlights how easily visual appeal can override scientific accuracy. But it also shows how curiosity, when paired with careful questioning, leads us back to the truth. The paramecium wasn't a comet, but it still reminded us how order and beauty can emerge at every scale, from the microscopic to the interstellar. The mix-up surrounding the 3I Atlas video isn't just a harmless misunderstanding. It reflects a growing challenge in the digital age, how fast misinformation spreads compared to verified facts. The false claim was simple, bold, and visually compelling, exactly the kind of content that platforms like X, formerly Twitter, TikTok, and Instagram tend to amplify. Algorithms reward posts that get reactions, not those that go through peer review. When a mysterious video appears online with a sensational caption, it doesn't need to be accurate to go viral. It just needs to be engaging. And with the rise of AI-generated summaries, some systems now automatically label content based on captions, which can repeat or reinforce false claims without verifying the source. Once these errors start circulating, they're hard to correct. By the time experts weigh in, millions may have already accepted the original post as fact. This is why fact-checkers and scientific institutions are more important than ever. Organizations like Lead Stories, Reuters Fact Check, and agencies such as NASA and ESA are working to provide transparent data, real telescope images, confirmed orbital data, and peer-reviewed studies that the public can access directly. These groups help slow the spread of misinformation by tracing claims back to their origin and identifying which ones hold up to scrutiny. For science communicators and astronomy enthusiasts, the best habit is a simple one: check the source. If a video or claim isn't linked to a credible observatory mission or scientific publication, it deserves skepticism. While the viral video fades into internet history, the real 3I Atlas continues its journey. In the coming months, it will be observed by the Vera Rubin Observatory and NASA's Sphere X mission, which will analyze its brightness, composition, and possible behavior changes. These missions could determine whether the object behaves more like a classic icy comet or something more rocky, dry, and unusual. Over the next decade, astronomers expect to discover dozens more interstellar objects. Together, they'll help create a new field, interstellar planetology, the study of materials born around stars far beyond our own. Every one of these objects helps build a bigger picture of how different star systems form, evolve, and sometimes eject their icy leftovers into the void, eventually passing through our own cosmic backyard. In the end, the truth was stranger and smaller than fiction. The viral video that captured the internet's imagination wasn't footage of an interstellar comet. It was a single-celled organism swimming in water. But the real 3-eye atlas, it's still out there, drifting silently through our solar system. No tale of viral hype, just a trail of scientific discovery. It's a perfect reminder that curiosity drives discovery, but truth is what defines it. Thanks for watching. Be sure to subscribe if you want to stay updated on everything happening in the cosmos, from confirmed interstellar visitors to the real stories behind the headlines. See you in the next video.